Okay, hello everybody. I'm very happy to introduce you shortly Flora and Martin Berger, the next two speakers in this virtual SOUG Day event. Flora is, I'm very proud to introduce Flora because she is, since this year, member of the Swiss Oracle User Group board and one of the organizer of this incredible event. She's one of the beating hearts of the Swiss Oracle User Group, and she just can do everything. She organizes, she presents, she loves biking, we noticed recently. And on the other hand, we will have Martin Berger from Trivadis, the Austrian Martin Berger. That's always a little bit of problem distinguishing the right Martin Berger, as Trivadis has two, one in Switzerland and one in Austria. He is a big friend of Flora, she told me. And looking at his CV, he had so many roles in his life and still very young. So I would like to give you the control and start the session.
Okay, thank you, Paolo. Good morning, everybody. And like Paolo said, my right arm is broken, so I only have my left hand. So the switch between slides may not be that smooth, but I guess you understand. So let's start. First of all, we wanted to tell you that it all started on Twitter. Actually, before DOAG 2018, it's a conference in Germany, I discussed with Martin on Twitter about solutions like connection managers and stuff like that. And we wanted to talk to each other about solutions to prevent access to databases. So during the conference, we had many conversations. And as you know, in some conferences, you are into sessions and then you have a 10-minute break, you have a small conversation, and then you go back somewhere else. So we only had many pieces of different conversations. And with the idea of Martin, we decided to turn all those conversations into a presentation. And this is the presentation we're going to make right now.
So, hello from my side as well. My name is Martin Berger. I'm the one from Austria, and I'm with Oracle since about 2000. So I know about it for several years already. You can reach me via the Twitter handle, via my email address. You can have a look at my blog if you really are interested in. And yes, I'm an Oracle ace, which only means I like talking about Oracle-related things. So that's all it says.
Thank you, Martin. So on my side, I'm Flora Barriele. I'm French, but I live in Switzerland. I've been in IT for 8 years and 5 years as a DBA. I love working in IT so much that I became a co-organizer of Gig Girls Carrots. It's a global organization which aims at promoting women in science and technology. I'm also an Oracle ACE associate, so I also love talking about Oracle stuff every day. And I work in a company called Swissquote. It's a Swiss banking group specialized in online financial and trading services. So you can also reach out to me via Twitter or my blog. So now let's jump into those conversations that we had. So first of all, Martin asked me a question.
Yeah, the obvious question from my side is, or was at that time, if you want to avoid someone connecting to the database, why not do it on the firewall level or on the network level with just a simple firewall or a set of firewall rules?
And actually my answer was, I'm not sure we can ask this to the network team. I'm not sure how much we can involve them in this security topic to prevent access to our databases. So the next question was,
yes, okay, we all know it's never a network issue. Let's find another solution. What about a dedicated instance for each of your dedicated listener for each of the instances, and then yeah, lock down who is allowed to connect to this instance or on that level?
So this idea could be very interesting to implement, but in this case, the problem was that I had more than 600 databases across 65 hosts, and using a dedicated listener for each instance would have been really difficult to manage.
Okay, at this stage, we decided it's a little bit more complicated. We need to understand what's really going on there. Do you see my screen?
Yes.
Okay, perfect. So we got together for several minutes and discussed what's really the core of the issue. And we came to quite simple explanation. We have to separate three different things. And on the bottom right side here, you have the databases. We have about 600 databases and want to manage access to them. But who is allowed to get access? On the other side, there's always users, or in Flora's case, there are users who want access to the database. We did not talk about applications directly. They are quite easy because you know them, you know on which server they're running. So it's about users. But why should the user have access to a database? It's this role in the middle. And it's not a role as we know it as a DBA from a create role statement. It's more on an application or a business level layer. So maybe there is a guy who's a DBA like me and should do DBA tasks in the database. So I'm not allowed because of my beautiful hair to access the database. I'm allowed based on my role as a DBA to access the database. And maybe there is someone in accountant or whoever. And maybe there's even this super guy who knows everything about IT and can fix every situation. But still, this person is not allowed to access a database because of the person. But he, at the moment, has this role of the super guy who knows everything. And if he switches role next week to something totally different in the company, he should be revoked all the permissions based on this role. This was the basic idea here.
Exactly, thank you. So allow me 1 minute to share my screen. Okay, here we are. So actually, like Martin said, the situation is we have to know the business roles of the people and how can we handle this situation better. So the first thing we thought about is that you have to understand your ecosystem. You have to understand how many databases you have on how many servers. Sometimes you're not aware that you have an old Oracle somewhere on an old server that everybody forgot about. You have to know which versions you have. You have to know how many different users, how many different applications are accessing those databases. So to make it short, you have to know who connects where. And at this time, instead of using old set of tools like grep and stuff like that, we decided to be more modern and use powerful tools like Splunk. So I'm going to give you a short information about what Splunk is, but the presentation will not be only about that. So Splunk is a powerful tool to collect and index real-time data from a huge amount of sources. And it's really cheap in terms of efforts, and the results are really handy and easy to exploit. And the special part about Splunk is that it has a special add-on for Oracle database. And this Splunk add-on allows you to parse things like alert log, audit logs, and of course, you can parse listener logs. So the alliance between Splunk and this add-on is a really good source of information because you can really exploit what's in your listener log and what is going on all your databases. So with a simple, quite simple search, you can get, like in this example, the number of connections from a specific IP address to a specific service or a specific SID. So for example, we have IP address 1234 that connects to the service called cool service 4,000 times in the last 15 minutes. That's the kind of stats you can have. Same, you can have IP address 4321 that connects to service called nice service 2,000 times in the last 15 minutes. So with a very simple query, you can really get exactly what is going on and who is connecting where. You can also have interesting things like this. So for example, the first chart shows how many connections have been made in the last 15 minutes to a specific host. So for example, we can see that host 5 has a lot of incoming connections. You can also have how many connections on specific services. So for example, the cool service and nice service, they're both on host 5, which is the host that was the most accessed. So it gives you a very clear idea of which services are more used than others. And to finish, there's a little bonus. Actually, it's not really in the scope of this presentation, but I really like it. We also used Splunk to bust who is still using SID to connect to databases. So we wanted to avoid applications and people to connect directly with SIDs. And this is an information we have in listener logs, and it's very easy to show it on a graph like that. So with this kind of very nice and visual dashboards, you can determine which service is more accessed on which host from which IP. And this is really easy to present afterward, to make reports, and managers really like things like that when it's the information is really easy and very clear to understand. So these examples and suggestions converge to the most important things that we want to highlight in this presentation, is that we can understand the situation and then we can choose a solution that fits our needs. So that is to say, when you have a problem, you can, first of all, really understand what's going on, and then you can start thinking about what will be really useful in your situation. So in the scope of this project, what was the problem actually? So that was the problem. The problem was that everybody is Waldo. You cannot distinguish people from each other. You have many different people from many different departments with different responsibilities. Sometimes they're on different networks. They use different applications. Sometimes you have people that are nice enough to share their credentials with their friends. So the key point here is that responsibilities are not always very well distinguished. So the question is now, how can we address that? What kind of technical solutions exist? What kind of technical solutions are more suitable for each situation? And this is what we are going to explain now. Martin, I think you're on mute.
Yes, you're right. I'm sorry for this.
Good, no problem.
Thank you, Flora. As Flora showed in our initial Twitter conversation, she asked about the connection manager. And as it will be part of the solution we show here, I would like to introduce it a little bit, as it's probably not the best known component in the Oracle ecosystem. So, sorry. Good. So the connection manager itself is, at the end, it's a listener and some gateway processes. They can run on any system. They can run on the same where the database is located. Then you need a different listener port, of course. But they can run on a dedicated server as well. So from my perspective, it makes sense to have it on a dedicated system. It can be virtualized, no problem there. but it keeps things much easier if you separate the connection manager from the database listener and instances as well. So the first thing you need to understand is there is a set of rules in a connection manager. These define who is allowed to connect and who is refused. And I see it as a best practice that the instance connects to the listener of connection manager and registers its services there. You can also define the services in the connection manager itself, but it's much easier and quite beautiful when the instances register themselves there. For the instance, you need to set the remote listener SP file variable, and then it's done easily. And the connection itself comes from the client here on the left side. It connects on network layer to the listener. If the rules apply, then the connection is handed over to the gateway processes, and they connect then to the listener again on the instance side, of course. And this connection is then handed over to one of the server processes on the instance. Some words about the rules. You see here a simple line. The format is quite similar to those you know from TNS names or other files. The rules are ordered. You will hear about it later a little bit more. And of course, you can have, come on. Yeah, here you can have a source and a destination. They can be either a dedicated host name or a network IP address, or even a network mask. So if you planned your servers quite well, you can aggregate several servers into one network and network mask and reduce the number of lines there. Then you have the service, the one the instance registered, and the activity, which can be either accept, reject, or drop. From the client perspective, if you cannot access, in some cases you see the reason why. This can be either the reject, then you get information that it's rejected. A drop is a simple connection closed. And of course, if there is no service at all, you get the normal information as you would get when you connect to the databases local listener directly. There is no difference on this side. As we have the problem of only one listener, there are times when you need to bring them down for patching or maybe operating system activities or whatever. But you can have several of these connection managers installed on different hosts. You can also have several of them installed on the same host, but then you still have problems if you want to patch the operating system or the VM goes down or whatever it is. There's one big disadvantage here. The rule set is not synchronized at all. So you need to copy the rules over on your own. There is no cluster manager or several or different solution for this. Unfortunately, it's on the administrator's responsibility. With a proper TNS names or file on the client side, it can connect either here or there, and then is redirected to the database's instance directly. For such a configuration, you need a slightly more complex TNS names or file as we are used nowadays, but those who do with Oracle for some more years will recognize this setting here. You have an address list and then several addresses, one for each of the connection managers here. In my case, there are only two, but you can have as many as you have connection managers. And if you set load balance on, then it really tries to load balance with them. So all the other high availability settings you can find in the documentation are applicable here.
Oops, that time it was me on mute. So can you see my screen? Is that okay? Okay, great. So after discussing this connection manager solution, we talked about another one that is called database firewall service. But for the rest of this presentation, I'm going to call it ACL, like access control lists, because it's way shorter to pronounce. So please keep in mind that this new feature is available started with Oracle 12.2. So what is this new feature and what's the concept? So imagine you have one database, so one container database with two pluggable databases. Each of them belongs to someone different. So the first one belongs to Waldo and the second one belongs to Odlo. Odlo is the bad guy in the Waldo books. So we want Waldo to access his own PDB and we want Waldo to access his own PDB. But we don't want them to access each other's PDB. So actually what we can implement with this new feature, it's an access control list directly in the database that tells, that allows you to control access to a specific service or of a database or to all the services of a PDB. So actually, an entry is a host allowed to access to a PDB or a non-CDB. So why am I talking about PDB and non-CDB? Is that this feature is available for multi-tenant, but it's also available if you don't use multi-tenant. So this feature allows you to protect the access to a specific service on the database, but there's an extra feature for PDB is that you can also restrict the access to a whole PDB without specifying each service, which is really convenient. It allows fine-grained access to each PDB regardless of the policies on other PDBs. So to implement this feature, remember that some modifications have to be performed on the local listener handling your database. So on the local listener handling your non-CDB or your CDB. So for example, I'm going to show you what happens when you try to connect to a PDB with an unauthorized IP. So you simply get this very explicit error that says listener rejected connection based on service ACL filtering. So you see the reason why the connection has been refused. So why would you want to use this ACL feature? So remember, it only works starting from Oracle 12.2. It allows you to have fine-grained access control on each database or each PDB. It is a very flexible solution because you can specify an IP address or a range of IP address using a wildcard. But the management is decentralized. So by this, I mean that the entries have to be explicitly defined on every database. So it's not a centralized solution. So like I said, it's only available starting from Oracle 12.2. So what other options exist if we still have, for example, a database with version 11G?
For all databases older than 12.2, we discussed about using logon triggers. So I assume everyone in the audience at least had heard about it because it exists for ages already. So I only want to summarize the concept a little bit. You can filter by host name, OS terminal, application mode, or IP address, or several other things from the session or the sys context, which means it should be sufficient to decide if a session is allowed to come in or not. The problem here as well, you have to have a map which describes who is allowed to connect to which user or which service or whatever, decentralized on each database. And you need to keep this updated every time something changes. It's a lot of work with 600 databases as well. And you have to have this local trigger on each database, and especially logon is very sensitive. There are some applications which does hundreds of logons per second. I don't like those, but they exist. And if something goes wrong in the trigger, you can log out a whole bunch of people or applications. So it's very sensitive to do logon triggers. Here's a simple example. So the important part here is after logon on database, you find out if something is allowed or not. And if it's not allowed, you just tell the user, you're not allowed here, please go away or contact your security manager or do whatever you want, but don't bother me. That's very nice to write it here, but often people does not even read such error messages and just say, I cannot log in, and then they raise a ticket. Go to the database administrator and so on. You all probably know about it. So there are some things to consider when using a logon trigger. So let's start on the right side. Come on. Yes. Here we are. If you do a logon trigger, please don't forget to log the reason of the rejections. This is especially useful if someone doesn't come at the moment, but after 2 or 3 days and say, I got this error message on my application 2 days ago. Why? And if the allowance map changed in between, you will never know why. If you write a proper rejection to a log file, then you can say, at that time, you did not have the proper IP address, or whatever the reason is. It's still a decentralized management, so a lot of effort to keep it in sync with whatever rule base you have. But the biggest advantage, here it is. Come on. It works with quite old databases. So I guess it was introduced somewhere at around 7. I don't remember, honestly. And if you have databases older than this, I assume you have other problems than who is connecting to the database at all. But there are other solutions as well. You can totally go without prohibiting any access if you really want to go that way. You can enable audit for logons and then report. The approach here is to have audit. You can have the audit either in the conventional way or the unified. So the minimum setting you need to have is to have an audit enabled, probably in the conventional, and audit only here, we are only on logon. And whom you would like to report to. The first idea is to send the users manager, dear manager, your colleague Joe connected to the database XYZ and he was not allowed based on the rules that please do something. But probably you know this manager, he will have a good reason why his colleague Joe was needed to access this database at that time, and nothing will happen ever. But there are different methods as well. You can enable unified audit here. It exists since 12.1, but I really recommend do not use it before 12.2. The implementation in 12.1 is kind of pain in the ass. And I personally recommend not only to audit log on, but also log off and any kind of DML you want to. That has nothing to do with the direct goal to keep people out of the database, but you can help in many other situations. And I assume if you're an operational DBA for some time, there was this situation where someone came to you and asked, see, I assume there was an index on this table and now it's gone. Do you know anything about it? And if you have the audit on DML, then you easily can say, yes, 2 days ago at 10 p.m., your colleague Joe dropped an index. So maybe you want to go to him and ask why he did it. And it's off your table in minutes, and you don't need to go back in time on some backup copies and see what was going on. And I also recommend not to send the notification, the report to the users manager, but to those who care about the application and its integrity a little bit more. An application manager will be very interested why user Joe was connecting, and if he does know user Joe does not belong to one of his team, then there will be a good reason for it. And also a security manager, or maybe someone responsible for GDPR or similar things, is much more interested to fix this, or maybe grant this person the proper role than the user manager who just ignores the daily email and continues.
Okay, I'm doing okay with the left hand so far. Okay, so after all those conversations about those several solutions we had for different versions, we started thinking about combining two of the solutions we presented. So we studied the perspective, the technical perspective, and also the management perspective of combining two solutions, Connection Manager and ACL. So I'm going to explain what we tested. It has not been totally implemented yet. It may not be a final solution, and discussions are still ongoing, but this is a sort of a summary of all the ideas we had. So with those two features, it looks like we should be on the right track. So let me explain you the whole idea. For example, you have three nice people, three Waldos, and they want to access to several databases. So what we discussed is that we can have connection manager between the nice people and the databases. And we could handle all the rules, all the access rules in the connection manager. So that is to say, who is allowed to connect to which service. And then on the databases themselves, we could use only the ACL to allow only one system to connect, and this system would be the connection manager. So if we're using grid infrastructure, we must consider that we have local listeners and scan listeners to protect also. So like Martin said, to be more to have a real implementation in a real world case, we would use more than one connection manager. Actually, we would use, for example, 3 connection managers behind a VIP to avoid a single point of failure. So what happens if someone with bad intentions tries to connect? So this person would be rejected by connection manager because this person will not be allowed in the policies of connection manager. But like I said before, if we use grid infrastructure, we must consider that we have local listener and scan listeners. So with the help of the ACL, we would protect all the access. Because even though the bad person tries to connect with the local listener or the scan listener, because this bad person is not allowed in the ACL, then it would not work anyway. So this concept is also a way to avoid using firewall protection on local listener and scan listeners, because this firewall protection would have to be implemented by the network admin. But since we only allow connection manager to connect to the database, whatever the bad person tries to do with the listeners, it would not work. So this solution is great, but what if we have some database with version 11.2? So like I said, ACL are available starting from 12.2. So with database version 11.2, we can implement a parameter called tcp.invitedNodes on the sqlnet.aura on the DB server. And in this parameter, we can specify which clients are allowed to access. But we still have one problem. Who takes decision about security policies? Like Martin said, when there's a user that complains about not being allowed to access a system, we would want to tell this person, it's not my business, I'm just a DBA. So we don't want as DBAs to take this responsibility. We want to give the responsibility back to the security team. So we want the security team to be the owners of the security policies, and we want them to manage the security policies. But how can we do that? How can we achieve this goal? I'm going to show you an example that can be implemented with Oracle Application Express, as known as Apex, which is quite convenient and quite easy to implement even for DBAs like me who are really bad at coding. So imagine the situation I described before. We have good people and bad people, and some of them can access some databases and some of them cannot. And we have here Wilma. So Wilma, she is the security officer. And we want Wilma to have a very simple web page where she can specify who is allowed to connect where. So basically, we want Wilma to take the responsibility to say, this person or this IP address is allowed to access this database and is not allowed to access this database. We don't want the DBA to do this. We don't want the DBA to be responsible for this. We really want to give the full power to the security team. So technically, she could create and modify access rules, and they would be recorded in a table. And for example, every night, this table would be transformed or translated into connection manager rules. So exactly like what Martin showed before in the connection manager chapter. So we would translate the map table to connection manager's rules and add them to the connection manager. We can also refresh the rules every 15 minutes if we want. So it's really up to us and up to what we want to do. So simply put, Wilma adds the new rules arrive in the map table, and every night we update connection manager with the new rules. So actually we would go from this. So this is what connection manager's rules look like. So you have a rule list, you have a source, a destination, a service, and an action. So accept or reject. So we would go from this syntax to this one. So this example shows a table representing the connection manager rules. So we have an ID, for example, the source, the destination, the service, the action. So that would be accept or reject or deny. The rule order, I'm going to talk about this in a few minutes. The description, of course, if we want to explain why the rule is here and what's the tracking number of this request. And we can have, for example, the update date of this rule. So what is this rule order I just talked about? So actually, connection manager is going to read its configuration in a specific order. And for example, a rule like this one, which means to reject everything, we want to have it at the end of the configuration file, because otherwise every new connection would be rejected. So in this table, we mapped this concept of the rule order by using, for example, rule number 1, number 2, number 3, and number 999 to be sure that this one is really at the end of the table. So combining those two solutions or studying those several solutions led us to think about several things technically, but also in the management topic, or how to really handle the responsibilities. So first of all, on the technical part, centralized deployment of policies can only be done with connection manager. But you can have very simple configurations on all DB servers with other solutions if it fits more to your needs. So before implementing a solution, you have to get to know your environment and have a good idea of the situation, have a good idea of who is connecting where and who is allowed to do what. So with all these and all these technical solutions, you need to make sure to always use the right one, the one that fits your needs. And also really important to keep it as simple as possible, not only for you as a DBA, but also for every technical team involved in the process. So you want to make things easier for the network team, for the database team, for the architects, for the developers. So you want to choose a solution that would approximately fit and be clear to everybody. You also want sometimes to educate the users and assist them in embracing those changes, and sometimes those are more of a management changes. So all of this, it's not only about DBA job, but it's also about non-technical perspectives and sometimes about organizational matters. So there is not one solution to rule them all, but even if we are techies, we have to juggle with a lot of non-technical problems. So this whole presentation is all about the choice of a solution that will fit your needs and your situation. Martin, do you want to add something?
Yeah, maybe because this was a big question in some previous talks, I'm sorry. This is not the solution. It is only the solution for this specific problem in this specific company. So please don't go and take a connection manager, take ACLs and deploy it in your environment, create a small Apex and just integrate them and then say you're fine and you're secure and everything is perfect. This will 100% fail. Our goal was only to show you there are different solutions and you can pick some, and there might be some others we did not think about in our conversation because it did not fit or we do not know about it. So don't rely on ours, just take it as a first step in your journey.
Thanks.
Yes, it's very good in time. Are there some questions? Please fill them in the Q&A and we try to answer them.
Yes, there is one question. It's from Jörg Sobotka. And he says that even it is only some kind of listener, Connection Manager is available only with the Enterprise Edition licenses. And it would be really good to add them to the as Standard Edition 2 licenses.
Yes, there is not a lot I can add to this. Jörg is right here. It's so the database must be in Enterprise Edition. It's not an additional license, but if you have a database standard edition, this will not fit. That's all. Oracle can change it. There is no technical reason for it, but it's not allowed. I don't want to talk about licenses in conferences, honestly. Some other questions?
Not quite now, but you are allowed to ask questions. Just put them in the question and answer tab. Well, let's wait another little bit of time if somebody has some courage to ask something.
And if you want to reach out later, no problem.
There's another question by Anastasia. If we think that Seaman will be maintained by Oracle in future versions or in the future, it's hard to predict Oracle's goals, but there is no de-support notice or anything in the new features guide, also not for 20. And Connection Manager is quite unique in some situations and useful, so it's unlikely Oracle will de-support it recently. But this is my private opinion about it, okay? I'm not the product manager.
I agree with what Martin said, and Connection Manager had a new version quite recently, maybe 1 year ago, if I'm not mistaken. So it means that Oracle will not abandon this product, I hope. And you have some very good material on the internet about this new version with the new features, and some of them are really complex and interesting.
I can try to get in touch with a product manager and reach out to Anastasia. And if somebody is interested, I will try to get some information about it.
Thank you. That would be great.
Thank you, Paola.
So if there are no more questions, I would really like to thank Flora and Martin for the amazing presentation. It was very interesting, and it was about use cases. It was about practical experience, and this is something that for the community, we are always very happy to share with them. So now the morning stream has ended. I want to remember you that this evening at 5:30, we will have the keynote with Gerard Benzel. Everybody who has registered should have received the email with the links, and hope to see you there. And very happy to go on this evening. Bye, and thank you very much.